Have you ever wondered how artificial intelligence, or AI, took its first breath in our world? Let's journey back to the 1950s, when the term artificial intelligence was first coined. It was a time of great scientific discovery and technological innovation. And in the midst of all this, a man named John McCarthy dared to imagine a future where machines could simulate human intelligence. And so began the dawn of AI. The era that we now fondly refer to as the knowledge graphs era was marked by the development of rule-based systems. These systems were designed to mimic human thought processes by following a set of predefined rules. Imagine a chess game where the computer calculates all possible moves and chooses the optimal one. That's a rule-based system in action. The idea was simple yet revolutionary. Could a machine think like a human? Could it make decisions based on a set of rules just like we do? This was a radical concept that sparked endless debates and discussions. However, the potential of what AI could achieve was too compelling to ignore. The pioneers of this era were not just creating rule-based systems. They were laying the foundation for a new realm of possibilities. They were setting the stage for a future where machines could learn, adapt, and evolve, just like us. They were planting the seeds of a revolution that would transform the world as we know it. From chess games to self-driving cars, from Siri to Sophia the robot, the impact of their work can be seen everywhere. And yet this was just the first step. The initial stage of AI, as groundbreaking as it was merely the tip of the iceberg. So, as we stand on the cusp of a new era, let's take a moment to appreciate the brilliance and foresight of those early pioneers. They dared to dream, to push the boundaries of what was possible. And in doing so, they changed the course of history. As fascinating as it sounds, this was just the beginning of a revolutionary journey. So, how did we move from simple rule-based systems to machines that learn like us? The second stage of AI, often referred to as machine learning, started to take shape in the 1980s and continues to be a significant part of AI development even today. The key transition here was a shift from systems that followed pre-programmed rules to systems that could learn from data and make decisions based on that learning. Let's take a moment to understand what we mean by learning from data. At its core, this involves an AI system being fed vast amounts of data and using that information to make predictions or decisions without being explicitly programmed to perform the task. Picture a child learning to identify dogs. They see multiple dogs of different breeds, sizes, and colors. Over time, they build an understanding of what a dog looks like and can identify a dog they've never seen before. Machine learning works in a similar way. Machine learning relies heavily on algorithms, which are a set of instructions that tell a computer what to do. These algorithms are designed to recognize patterns within data. As they process more and more data, they learn and improve their ability to make accurate predictions or decisions. Statistical methods play a crucial role in this stage of AI. These methods help in identifying patterns and trends in the data, which the algorithm uses to learn. For instance, statistical methods can help an algorithm identify the correlation between two variables, say the weather and ice cream sales. If it's sunny, the algorithm learns that ice cream sales are likely to go up, and vice versa. However, it's important to remember that machine learning isn't perfect. It's only as good as the data it's been trained on. If the data is biased or flawed, the predictions and decisions made by the AI could also be biased or flawed. This stage marked a leap in AI's evolution, but the best was yet to come. Now imagine AI systems that can learn and think like a human brain. Sounds like science fiction, right? But this is the reality of the third stage of AI, known as deep learning, which began to revolutionize the field in the 2010s. Deep learning is a subset of machine learning, and here's where things get really interesting. At its core, deep learning utilizes something called neural networks. These are computational models inspired by how human brains work, designed to recognize patterns. Just as neurons in our brains are interconnected, so are the nodes in these neural networks. These networks are not just a single layer of nodes connected to each other. They are deep, with multiple layers, hence the name deep learning. Each layer takes the output from the previous layer, processes it further, and passes it on. This way, the system can learn from vast amounts of data, constantly adapting and improving. But what does this mean in practice? Well, deep learning has found applications in numerous areas. Take speech recognition, for example. Every time you ask your smartphone a question, deep learning algorithms are at work, interpreting your words and figuring out the best response. Then there's image recognition. Those nifty features on social media platforms that can identify faces in your photos. That's deep learning. It's also being used in healthcare to detect diseases by analyzing medical images. And let's not forget natural language processing. This is the technology behind your email spam filter or the recommended replies in your messaging apps. It's even being used to translate languages in real time. So what we're seeing is an AI that's becoming increasingly sophisticated. An AI that's not just following instructions, but learning, adapting, and evolving. It's a thrilling and perhaps a little daunting prospect. Deep learning brought us closer to the dream of creating machines that can truly think. With these advancements, we've taken a significant step towards a future where AI is an even more integral part of our lives. And that future may be closer than you think. So, where is AI heading? What does the future hold? The answer to that question lies within the prospective fourth stage of AI, contextual adaptation. Imagine stepping into a future where AI isn't just processing data, it's understanding context. It will be capable of learning not only from the raw numbers and facts it's fed, but also from the situation, the environment, and the unique circumstances it finds itself in. It's like teaching a child to not only understand that fire is hot, but also to comprehend the danger of playing with matches. This future AI will be able to adapt to new situations, learn from them, and improve its performance. It's not just about the ability to respond to questions or execute tasks, but to comprehend the underlying context and adjust its actions accordingly, just like a human would. For instance, a future AI assistant wouldn't just tell you the weather forecast for the day. It would understand your personal preferences, your schedule, and offer suggestions like, "It's going to be a bit chilly today. You might want to take your coat as you have a long walk from the parking lot to your office." But with such profound capabilities come critical implications. As AI becomes more contextually aware, it will also become more powerful and autonomous. This raises significant ethical and societal questions. How will we ensure that AI is used responsibly? How will we prevent misuse of this technology? And how will we handle the job displacement that could result from AI taking over more complex tasks? Yet, despite these challenges, the potential benefits are immense. From revolutionizing healthcare to combating climate change to enhancing accessibility for people with disabilities, the possibilities are as vast as they are exciting. As we stand on the brink of a new era, one can only imagine the possibilities that AI holds for our future. In a span of 7 decades, AI has indeed come a long way, hasn't it? From the humble beginnings of knowledge graphs to the sophisticated, deep learning systems of today, we have progressively moved towards creating machines that can think, learn, and adapt like us. Let's take a quick step back to appreciate this journey. We kick-started our exploration with knowledge graphs. This phase was all about teaching machines to understand information, much like how we read a map. It was a time when machines began to understand the world in a structured, logical manner. Then we ventured into the realm of machine learning. No longer were machines just understanding information, they were now learning from it. Like a child learning to ride a bike, machines started picking up patterns and making sense of data, all on their own. This learning took a deep dive with the advent of deep learning. Here we saw machines not just learning, but learning in layers. It was like peeling an onion, with each layer revealing a deeper understanding of data. Machines could now recognize a cat in a picture, or translate a sentence in French to English, tasks that we humans take for granted, but are incredibly complex for a machine. And now, we're on the brink of the next stage, contextual adaptation. Imagine machines that understand not just data, but the context of that data. They would be able to interpret the nuances of human language, understand the subtleties of our emotions, and adapt their responses accordingly. It's like teaching a machine to understand sarcasm, or the difference between a smile of joy and a smile of discomfort. As we continue to push the boundaries of AI, we are not just creating intelligent machines, but shaping the future of our world. The journey thus far has been nothing short of fascinating, and it's only going to get more interesting from here. So, let's keep learning, let's keep evolving, and let's keep shaping the future, one AI at a time. Thanks for watching. I genuinely hope that this video has been of value to you.